Okay, Algebra 2 fans, our topic for today is dividing polynomial functions and what we call synthetic division. Before we start, let me give you your joke of the day. What do you call a can opener that doesn't work? And the answer is a can't opener. Alright, so dividing a polynomial by a monomial. Poly means many, so if you have many terms, dividing it by mono is 1. So for example, in number 1, 2x to the 6th minus x to the 4th, that's a binomial, 2 terms, and we're dividing by one term, x to the 3rd. When you divide by a term, you're taking everything in the numerator and dividing it by the denominator. So you can break it up. You can say 2x to the 6th over x to the 3rd, and then minus x to the 4th over x to the 3rd. When you divide variables, we subtract the exponents. So this would be 2, 6 minus 3, we get x to the 3rd, and then minus. This would be 4 minus 3 is 1, so it's minus x to the 1st. And that's as far as you can take it. We can't subtract that because they're not like terms. They don't have the same exponents. So we're done. In number 2, we're going to do the same thing. Everything gets divided. Everything in the numerator gets divided by the denominator, 7y to the 3rd. Again, you can break it up, but you don't really have to show all that. If we do 28y to the 5th divided by 7y to the 3rd, 28 divided by 7 is 4. Subtract the exponents, so we get y squared. And then this is negative 21 divided by 7, that's minus 3. Y to the 3rd divided by itself, if you subtract the exponents, you get 0. Anything to the 0 is equal to 1. So this is really just minus 3 times 1, or minus 3. And then plus 49 divided by 7 is 7. Y to the 6th divided by y to the 3rd is y to the 3rd. And again, if you look at your terms, that's as far as you can take it. We can't combine because they're not like terms. Alright, now going back a little bit further here, this is you had done this in Algebra 1, okay, so it's a little bit of a review. Let's talk about long division, which you may not have done for a long time, for many years. So recall, if you do 478 divided by 7, so we set it up here, 7, and it goes into 478. So you ask yourself, 7 goes into 47, how many times? And that would be 6. So we put a 6 up here. 6 times 7 is 42. So 7 goes into 47 6 times, but then if I subtract this, I have 5 left over. And then the 8 comes down. So I bring down the 8. So I get 58. And now I repeat the process. 7 goes into 58 8 times. 8 times 7 is 56. Subtract, and we get 2 for that. 2 is your remainder. So the answer is 68 with a remainder of 2. So now you may have written this when you were in elementary school. You may have done 68 R2, remainder 2. I'm going to write that differently. I'm going to write it as 68. Now I still have the 2 left over, and it's being divided by the 7. So it's 68 plus 2/7, or 68 and 2/7. And just to show you, if we do 478 divided by 7, we get a decimal. And if I do 68 plus 2/7, I get the same decimal. Okay, so that's correct. So what I do at the end there is I take my remainder and I divide it by this number here, the divisor, okay, which is 7, and I write that 68 plus 2/7. So how would this work then with dividing a polynomial by another polynomial? So it's not just one term. I can't just break it up and do x to the 3rd divided by x, because I'm not dividing by x, I'm dividing by x minus 3. Well, we can do long division. So here's what it would look like. So I set up x minus 3 into x to the 3rd minus 4x squared minus 7x plus 10. Now, when you're trying to figure out what goes into what, you take the lead term of your outside expression and you take the lead term of your inside expression. That's what I'm dividing. So x goes into x to the third. It would be x squared times. Okay, x to the third divided by x will be x to the second. Now I take this number up top and I multiply it by this expression here. X squared times x is x to the third. X squared times negative 3 is minus 3x squared. Now what we do is we subtract that to get what's left over. X to the third minus x to the third is 0. Okay, so that's gone. Now you got to be careful here. This is negative 4x squared minus negative 3x squared. Now that's going to become plus 3x squared because I'm subtracting a negative. So what happens, I'll put that negative there, and then this becomes a plus. So negative 4x squared plus 3x squared is negative 1x squared. And then we bring down the next term, which is minus 7x. And now you repeat the process. X goes into negative x squared. If I divide that, I'll get minus x to the first. I'm going to now multiply that, so I get negative x squared. Negative x times negative 3 is plus 3x. So now we subtract that. Now again, what happens, I'm going to distribute this minus. So this will become a plus, and then this will become a negative. Negative x squared plus x squared is 0. Negative 7x minus 3x is negative 10x. Then I bring down the next term, which is positive 10. One more time. X goes into negative 10x. If I divide those, I get minus 10. Now I multiply negative 10x. Negative 10 times negative 3 is positive 30. So I subtract that. Now again, I distribute the negatives, so this becomes positive 10x, and this becomes negative 30. Negative 10x plus 10x is 0. 10 plus negative 30, 10 minus 30 is negative 20. Now that's the remainder right there. Okay, so the way I'm going to write the answer, my top expression here is the first part of the solution, x squared minus x minus 10, but I do have a remainder. Now I'm going to write the remainder as a fraction like I did here. So I take that number, which is negative 20, okay, minus 20, but that's still being divided by x minus 3. So I still do have a fraction here, minus 20 over x minus 3. This is the solution. Now you're probably asking yourself, is there an easier way to do this? And the answer is yes, because this is kind of a tricky process here with all the variables and also with the subtraction. So the method that we have is called synthetic division. And the way that it works, okay, I'm going to rewrite the problem here. So we had x to the third minus 4x squared minus 7x plus 10. Okay, I'm going to redo problem number 3 and then divide it by x minus 3. Think of x minus 3 as a potential factor. Potential factor. Which means, what I'm asking is, does x minus 3 divide evenly into this expression? In other words, would the remainder be 0? Now we already know the answer to that is going to be no. The remainder is going to be minus 20. Okay, and then minus 20 over x minus 3. But we can test this. If this was the factor, then that means that it would be a 0. Okay, if I was solving this equation, setting it equal to 0, if x minus 3 was a factor, then the 0 would be x equals 3. So here's how I set this up. On the side here, I'm going to write 3. And I'm going to kind of line this off. Now, I'm going to write the x to the third minus 4x squared minus 7x plus 10, but the way I'm going to write it is only with the coefficients. So 1x to the third, negative 4x to the second, negative 7x, positive 10. Now, by the way, if I was missing an exponent term, let's say there was no x squared term, I would put a 0 in that place. So it's kind of like a position on a number. You have to, each place holds a value. Okay, now here's how it works. What I'm going to do, the advantage to this is we're going to be adding for the most part. I bring the first number down, which is 1. I take that number and I multiply it by this number, which is 3. 1 times 3 is 3. And now I'm going to add. Negative 4 plus 3 is negative 1. This number is going to multiply the 3, so that's negative 3. Negative 7 plus negative 3 is negative 10. Negative 10 times 3 is negative 30. 10 plus negative 30 is negative 20. Notice that the last number, negative 20, is the same as what we had for the remainder. That's always going to be true. Notice that the other numbers down here, now these are coefficients, 1, negative 10. Notice that what we had up here was 1x squared minus 1x minus 10, negative 10. So this is what we call the depressed polynomial equation. Now, when I say depressed, I'm not talking about being sad, okay? Depressed means below. So this is what's left over. Now, the way that you read this is from right to left. This is the constant term. This is the x to the first, and then x to the second. If you kept going, the next would be x to the third, and so on. So what we end up with is 1x squared minus 1x minus 10, and then plus, or you could say minus, we could say minus 20, divided by the original factor, x minus 3, okay, by your divisor there. So notice that you end up with the same value, that you get the same answer to that, but notice that it's a lot cleaner because you're not having to deal with all the variables until the very end. This is called synthetic division. Now, another use for this is if I was going to substitute, if I think of this as a function, x to the third minus 4x squared minus 7x plus 10, that was the function. If I was going to evaluate f of 3, so in other words, what's the y value when the x value is 3? Well, what I would do is I would plug in a 3 for all my x's. I would do 3 to the third minus 4 times 3 squared minus 7 times 3 plus 10. So this would be 27. This is a 9 times 4, so I get minus 36. This will be minus 21 plus 10. And if I combine all of those, what I get is negative 20. In other words, I get the exact same thing. I get the exact same value that I get from doing synthetic division, or it's my remainder. So when you substitute values for x, when you plug those in, you're actually doing division just without thinking about it, and this ends up being my remainder. Okay, so it's kind of a cool connection that if you do the synthetic division, whatever number you end up with at the end there, that would be the same as plugging that value in to the function and just working it out. And that's the end of part 1.